Right, OD, good to go.
Thank you. So good afternoon, everyone, and welcome to the fourth episode of SCM Talk Show Session 4. The last episode, which we had 2 years back, 2 weeks back, was on changing paradigm of global supply chains. This episode on smart factories, myths and realities. So we choose usually topics from the responses to the survey that you have given. And we also seek a good speakers and availability of speakers, and that is how we choose topics. As usual, this session also will be recorded and made available free on KnoWerX mobile app and also YouTube channel, our YouTube channel, KnoWerX YouTube channel. And similar to our earlier practice, we are putting everyone on listen only mode. And like all other times, please submit your question in the chat box. We will take few questions, most asked questions at the end of the session if time permits. So it's my pleasure to introduce today's speaker, Mr. Boman Moradian. Mr. Moradian is a manufacturing productivity consultant at several organizations, and I know him for a long time. There is no, I think, parallel to him in terms of improving manufacturing productivity. He is a 1973 graduate in mechanical engineering from VJTI Mumbai and 75 postgraduate in operations management from Jamnalal Bajaj Institute of Management Studies. And incidentally, he's been a visiting faculty at Jamnalal Bajaj Institute of Management Studies for a very long time. I think maybe more than 30 years or so. So totally, he has more than 45 years of experience. He was directed at SL Propack, and I know one case study when he turned around SL Propacks, the manufacturing, and Garware High Tech Films. He is director at Cabra Extrusion Technique and Mutual Industries. As I said earlier, he has a lot of interest in teaching and is a very sought after a professor, if I may say that. He is a visiting faculty at Jamnalal Bajaj Institute of Management Studies and also at SP Jain Global School of Management at Dubai as well as Singapore. So he was just telling me that he just now finished a session at SP Jain Global School of Management, which extended to about 3:30 or so. So the name of his consulting firm is Telesis Consulting Services. So this is a brief introduction. I mean, his introduction probably will be very long if I start giving. So welcome, Mr. Moradian.
Thank you. My pleasure.
So thanks to you, in fact, for accepting our invitation and that too at a very short notice to share your practice-oriented insights with our listeners. And I would say that, there is nobody, I think, in our country who can provide a hands-on and practical, experience than you. I think you have done a remarkable job for the industry. So thank you so much, and over to you, Mr. Moradian, now.
Thank you very much, Ravindra. It's a pleasure and thank you for the kind words. To the participants, welcome. And I'll take you through a fundamental understanding of smart factories. I will a few videos and I will show you an application of how smart factory can lead to success as well as failures. And I'll give you a framework of what I believe would be the kind of issues that you have to address. What is smart factory, etc. We will see. So let's begin. And Ravindra, you just guide me. If you can have any problems on visual, just tell me.
Sure, sure.
So I'm starting now.
So I can see the PowerPoint.
You can see the PowerPoint?
Yeah.
Okay. So here we are talking about smart factory. First of all, before we start, ultimately, why does manufacturing exist? Because it has to meet certain customer requirements. Now, whatever kind of a setup you may have, lean, non-lean, batch, smart, etc., customer is not bothered. What is it the customer is looking for? So a manufacturing performance of any production system or even a service organization has to meet customer requirements to be successful. As simple as that. Customer doesn't care how you produced it. or how you generated the service. The customer is looking fundamentally for something called QSDFP. And now what is Q? Q is quality. Quality is a must requirement. You can't play around with quality. This is what the customer wants from your operating system, whether manufacturing or services. S stands for speed. Now, speed is a differentiator. Can you be faster than your competitor? Then you have a competitive advantage. Similarly, the customer is looking at dependability, on-time delivery. This is also a must requirement. When I say must requirement, means you may not be able to retain a customer if you fail on these. These are very sensitive issues as far as customer is concerned. Speed is a differentiator where you have to be better than your competitor. Similarly, manufacturing is expected to be flexible. Flexible means be able to change. Change to what? What the customer wants. And fundamentally, from manufacturing perspective, it means nothing but producing varieties as and when the customer wants. This is also a differentiator. You have to be better than your competitor there. And finally, the customer is looking at price. Now, when it comes to price from a production perspective, it means internal cost, fundamentally. And it's a differentiator only for commodities. Commodities sell on price. Any other thing other than a commodity, if price is the differentiator, is a real differentiator, you have a problem. That means there is something weak in your operations, whereby the customer is talking about price. So take any product, any service, ultimately the customer is looking at these 5 things. Okay, so let's continue. Now, what are the basic manufacturing parameters on which we see how production is performing? What are the key performance indicators, what we call as KPIs? What is your process lead time? The time you are committing to the customer. What is your on-time delivery? What is your CPK? Means with a certain industry specific sigma quality level. Is your process capable, repeatable, stable? So batch to batch, are you getting similar quality or not? These are the things we measure when it comes to production. What is your OEE? That is your overall equipment effectiveness. Your investment, your money is tied up in equipment. You are paying a heavy price for it in terms of depreciation and interest, and you have to pay back the original money which you have sunk into the system. What is the effectiveness of its utilization? And lastly, what is your cycle time? Means I put in the material and I get the final product out, which means you are adding value as well as lot of waste, non-value added time. This is fundamental measurements of what we look at when it comes to how well your manufacturing is geared to. How is it performing? Now, one thing you must remember is that the necessary condition for on-time delivery is that your cycle time, material in to material out, has to be shorter than the expected delivery time. It's simple. Okay. I hope this is clearly understood. What the customer wants and what we measure when it comes to operation. Customer wants quality, speed, dependability, flexibility, and price. And internally, we measure process lead time, on-time delivery, our process capability. Is it stable, capable, repeatable? OEE, which is operation, overall equipment effectiveness, and cycle time. Now, you must have come across this word lean all the time. Now, what is a lean system fundamentally? Lean shortens your cycle time. So lean leads to what we call as speed as a differentiator. Now, what are the necessary requirements of lean is cycle time reduction, and that is your work in process necessarily has to be reduced, which fundamentally leads to a single piece flow for manufacturing. Your layout has to be changed. Single piece flow is a necessity for lean. Batch itself is a different ball game. We'll come to that later. So one thing is single piece flow is a necessity. The second one is a huge necessity for becoming lean. Eliminate all kinds of uncertainties in your system. Stabilize the processes. Zero breakdowns, zero rejection, zero rework, zero design changes, zero effect of absenteeism on the system. Remove Mr. Murphy, as we say, Murphy's law should not work. Uncertainties have to be eliminated and mastered. That means the processes have to be made capable, repeatable, stable. And for lean, you need quick changeover mastery. Say there are 15 processes in the lines in single piece flow. I must be able to change over from one variety to the other quickly on all the 15 processes. That is a problem with lean. So we try to get into lean working, but if there are a large number of processes in the root, you have to quickly change over because you can't start the next variety unless all the processes changeover has taken place. Therefore, lean is very effective when manual work is concerned because you don't need changeover for humans. They can do from one variety to the other very quickly. But when it comes to equipment changeover, lean takes a beating because you have to do it all together quickly. Now, what about batch manufacturing? Many manufacturing systems are still based on traditional batch manufacturing instead of single piece flow. Batch inherently leads to high WIP and therefore necessarily high cycle time. Because the batch moves from one process to the other, to the other, to the other. No single piece flows. And try and understand batch is inherently required. They are appropriate for large variety, very low volumes each businesses. And please remember one thing. The market is moving. Marketing will force the organization to play large variety game, niche markets, something special markets. Okay, and then we'll see how smart factories score against this. So batch is very appropriate when varieties increase and volumes of each one reduces. So you're playing the variety game, and remember that's where the margins are. Say for example, Dow, Pierce, Lidl, Lifebuoy Personal, Lux International. Their margins are much more than Lifebuoy Soap or Lux Hamam Rexona. These are the varieties game. They are niche. They are for different market segments. The margin on Dove and Pierce will be far more than what you can make on Lux. And that is where marketing is moving the organization. Another place where you need batch, you can't do a damn about it. That is non-discrete products. What about textile fabrics? What do you mean by single piece flow? I can't. What about pharma formulations? I have to prepare the batch together. Are you clear? So they are necessarily batch. You can't do away with it. And similarly, changeover times for a line of machines can be expensive and we have no choice but to go for batch instead of just single piece flow. When there are a large number of machines in the route, in the process route, we can't do mastery of changeovers quickly so much unless it's only manpower oriented. Therefore, assembly lines are necessarily single piece flow. But what if there are 15 processes? You can't change over all the 15 at one go. So changeover times can be expensive. Then you have no choice but to depend on batch. Also, you can apply many of the lean principles in batch. First, you start with the bottleneck equipment. What is the constraint in the system? where you then start applying lean principles of eliminating uncertainties first. And then by the time you master it, you can go to the next equipment and the next equipment. In textiles, we have done it. Identify the bottleneck, first master it. No rejection there, no rework there, no uncertainties there, no breakdowns. So what are you doing? You are improving the effective capacity of that system. So we do apply lean principles except for single piece flow, even in batch. Now, what is smart factory? Let us have a look at it. There are different terminologies used. It's also called industries version 4 or 4.0, manufacturing 4.0, e-factory, industries 2025. This term was coined at 2011 Hanover Fair in Germany. The interest of the German industry for Industries 4, which we call smart factories, initiative is huge due to the fact that government at that time released 250 million euros to explore potential for it. So it was highly subsidized by the German government. But remember one thing, the key partners for smart factories or Industries 4 initiative are not SMEs, but big multinational enterprises or MNCs as we call them in India. Also on the I'll just mention it on the side. Please understand 50% of India's exports are done by SMEs. Okay. The bank loans SMEs have taken compared to the total industry loans is only 16%. There are 43 million SMEs registered in the country. It employs 20% of India's workforce outside agriculture. And you have to keep that perspective in mind. So is smart factories geared to meet this big chunk of the industry, which finally contributes hell of a lot? It contributes to the GDP $500 billion, by the way. Services contributes a bigger chunk, not manufacturing. Services 49%, manufacturing is 25%, agriculture is 16%. The rest is a little bit of defense, etc. is also considered contributing to the economy. So we are talking smart factories and we have to keep that perspective in mind. So what is Industries 4? Let me show you briefly a video. There are 3 videos. I'll just quickly run through them. Ravi, you just tell me if you can hear it.
In the history of industry,
I can
there
hear.
have been many revolutions.
Yep.
And now we're facing the next one, connectivity. But how can a company handle this? What does the industry of the future look like? Our experts have been wrestling with these questions for years. They know that the complete digitalization of the manufacturing industry plays a key role in the process. Why? That's simple. In the future, it will be more important than ever to operate quickly, flexibly, and cost-effectively. Product life cycles are becoming increasingly shorter, while product variants are becoming progressively larger. Just like large volumes, small quantities must be produced economically.
Varieties are increasing, small batches.
Lead times will become shorter, so that delivery must become faster. For companies, this means that in the future, they must align their organization much more rigorously to meet customer needs. This can only be achieved if companies start today to digitize, automate, and above all, interconnect all processes. Not only within the company, but also along the entire value chain. This means a convergence of the various areas. Customers and business partners are part of the total process. The goal is to make all relevant data available anytime and be able to control the whole network of value creation in real time, from product planning and product and production development all the way up to production and logistics. Of course, data security must be assured at all times. Synchronizing digital and physical value streams not only increases productivity of companies, but also their efficiency, quality, and innovative capacity. The Industry 4.0 concept isn't new, but unlike before, we now have the knowledge and technology for it to become affordable reality. As you can see,
Next video.
in the history
Now it will give you some more understanding. Ravi, you can see the video and hear it?
It is not started yet. There's a blank screen.
No,
Any
first
sound.
one you could see, no?
Yeah, absolutely
Okay,
clear.
okay.
Yeah,
No, I'm just talking about it. Ultimately, what Industry 4 does is you have to automate your processes and all the machines get integrated through the incoming supplies and outgoing supplies too. So they are all integrated and they talk to each other. The commands are given whereby your entire factory can be part of the supply chain. Now, what is Industries 4.0 further? What does it call for? Let us see. That is smart factory.
Yeah, the voice is clear.
You can see that, Ravi? Give me a thumbs up.
Yes, absolutely.
I'll stop this video here. Now I'll play another one to show you a smart factory in Germany. Okay? And just see what it means.
In the factory of the future, both the workpiece and the machine will be intelligent. They will be completely networked and control production autonomously, and in a way that is more efficient and uses fewer resources than ever before. The possibilities are so vast and groundbreaking that many experts refer to it as a fourth industrial revolution, Industry 4.0. The first steps towards Industry 4.0 have already become reality. It all starts when mass production components become a unique item, with their purpose predefined at the outset. Because even before manufacturing, the component exists in virtual reality, including all information required for its production. But all the other necessary components also have to be mapped into the virtual world. They also get names and addresses, and thus an identity, so that they know where and when they are needed in the production line or process. Equipped in this way, they are able to negotiate their way through the digital factory for kilometers before reaching their destination. Arriving at the processing station, the workpiece is identified and the machine calls up in real time all information needed for processing. After each station, the work gets checked automatically, either optically or by using other measurements. Deviations from target specifications can thereby be discovered on the spot and faults can be eliminated quickly. If a machine needs replenishment or maintenance, it issues an appropriate request before shortages or breakdowns are experienced. The amount of resources used is immediately recorded in the system and stocks get updated. During processing, all relevant data for the product is stored in its own digital product memory. This means that every stage of production can be traced precisely. In the factory of the future, machines and workpieces will even communicate directly with each other and make autonomous decisions about the next production step, comprising a system that is decentralized, efficient, and flexible. For this, so-called cyber-physical systems are the key enabling technology. But for all this technology, humans are still crucial. Even in a highly automated production environment, creativity, experience, and the ability to assess and evaluate situations remain irreplaceable. But technology can provide valuable support. Operator-safe control systems already allow automatic and manual production to be combined. And regarding quality control, employees use augmented reality to determine whether the product meets the required quality standard and can be shipped to the customer. Electronics and software allow for ever higher levels of networking to be reached. Completely new, complex systems are being developed in next to no time. The German electronics industry is at the heart of this rapid change with its own innovative products.
Okay. Now I'll stop sharing and I'll start talking to you. So what is this? What is this smart factory trying to do? It's some Internet of Things. It's a totally connected world with smart devices attached to every piece of equipment and the component. I hope you are clear. I hope you can see and understand what I'm saying. You can see me or you are seeing the screen now, Ravi?
You can see you as well as screen both.
Okay, the screen is only blue. Okay.
Yeah.
So machines as well as the components have devices attached and all the time they are talking to each other. Your control hardware allows two-way traffic. So all the machines are interconnected and they talk. All plant equipment can talk to you by giving necessary data and insightful analysis for action. It gives commands that this part is arriving, that part will now arrive. It's all sequence, what to do on that job. Okay. Equipments talk to each other to improve productivity. You can do resource planning, production planning, even machine scheduling, in advanced information gets done. That's smart factories. Okay. All your data is on the internet. That's one more thing to be kept in mind. Okay. Now let me continue with my presentation. So what is a smart factory? Let us try and understand this. Smart factory integrates Internet of Things to an existing manufacturing system that is supply chain integrated and Internet of Things controlled manufacturing system. From the supply in to the integrated system and out. The supply chain integration extends to inbound and outbound logistics to available workstations and WIP ready to be processed. Every damn piece is tracked online in real time. And every piece is planned in real time and you can see the progress of it happening. So actually, if you ask me, smart factories is the next generation of supply chain management fundamentally with physical shop floor scheduling, matching incoming materials and arriving orders with maximum flexibility forming a cyber physical production system. So what is smart factory actually? It is all nothing but the next generation of supply chain management. We have digitized to a large extent incoming and outgoing. What was missing is the factory in between. So it is now integrating that with the physical shop floor scheduling, which matches incoming materials and the arriving orders, providing maximum flexibility. I mean, I start wondering, shouldn't it be called supply chain management version 2 or industry version 3? But you know, people love to call it different names. So it became industries 4 or smart factory. It is the next level for supply chain management. Incoming and outbound was already digitized and automated to a large extent. The factory in between, the scheduling part remained. And now we have the smart factory concept or industries 4. To me, it appears to be supply chain management next level version 2. It entails dynamic programming of routing of orders and products via automated material handling system, automated guided vehicles, connecting different equipment, workstations, ultimately to achieve fully flexible manufacturing system. These workstations need to be linked by an optimized network-like model structure. They are all interlinked. They talk to each other. They understand this part is not coming. There was a problem there. Whatever. No manual intervention. Full information on whereabouts of parts and machine breakdowns, rejection, rework, etc. ensures increased flexibility. You're not taken by surprise. I hope you can see my screen. Ravi, you can give me an indication. Yes? Hello?
Yes, we can see that.
Okay, screen. Now let me take you to this typical case of Tesla Model 3 at their plant in Fremont, California. What a beauty of a car. A fully integrated factory, smart factory, devoid of humans, only machines. It was the best car of the year, this best design car of the year by so-and-so magazine, best car of the year by so-and-so magazine, best electric car, best company car, best safety award, Golden Steering Wheels Award car of the year in Denmark, in Norway, Switzerland, UK car of the year, etc. Now what they did was 95% of the assembly has been automated, no human intervention. They all are interlinked and talk to each other. Nobody has done it. Tesla did it. And this is what Elon Musk mentioned. This is just going to be a very difficult thing for other manufacturers to copy. I would not know what to do if I were in their position. The plant was supposed to start in 2017 and produce 100,000. One model, huh? There's not even variety, by the way. Color is not a variety. And would be ramped up to its capacity of 400,000 cars in 2018 and continue 2019 onwards. What actually happened? In the first half of the year, 2007, second half, first half was zero. Instead of 100,000 cars, in the second half, they could produce 2,700 cars. In 2018, first half should have been 200,000. They produced only 38,000. Then something happened in the second half. It went to 115,000, increased to 135, 168. What happened? This is what Elon Musk had to say. Excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated. You know, all these automated interlinked facility and all that is all very good. But you need the humans to understand things. Machines can't think. You may build in a lot of artificial intelligence and machine learning. Ultimately, you need discretion to be used at several places. So what went wrong? Let us have a look at this video.
I definitely feel stressed. Yeah, it's like we've been incredibly difficult and painful the last several months.
The robots are killing Tesla. In a rare win for humans over robots in the battle for labor efficiency, Wall Street analysts have laid down a compelling argument that over-automation is to blame for problems at the billionaire Elon Musk's electric car company. So what went wrong? The Tesla Model 3 production line is heavily automated, and right now that's a problem. During the company's third quarter earnings call, CEO Elon Musk told investment analysts that the $35,000 electric car, which launched this summer to much fanfare, has struggled to reach its lofty production goals because of issues with manufacturing. Automation will certainly prove faster in the long term, but in the short term, Tesla can't switch out its army of robots for humans. In early 2017, Elon Musk told stock analysts that Tesla's goal is to be the best manufacturer on Earth. He'd get there by inventing a factory so dense with robots and devoid of human beings it would resemble an alien dreadnought video game warship.
We call it the alien dreadnought. At the point at which the factory looks like an alien dreadnought, then you know you've won.
Speed, he said, is the ultimate weapon when it comes to innovation or production. Instead, Tesla this week was forced to bring the Fremont, California production line of its crucial mass market
I'll stop this here
Model 3 electric.
and I'll proceed. What is the result? Actually, automation in assembled products is statistically inversely correlated with quality. You know, all these interlinked robots talking to one another as the part arrives and what happens is so densely mechanized a robot, when it tries to install a nut or a bolt, and if it's a defective bolt, you have a problem. It breaks the part, it damages the part where the bolt is applied. Then you need another sensor on the arm of the robot to see whether the bolt is bad or not. A human can do it damn fast. Typically, there are 10 labor hours in assembly of a car, of electric car. Normal car is about 16, 17. By automating, what did he do? He reduced 5 labor hours, but the saving was $150 per car, considering $30 per hour. But who's going to maintain these machines? We tend to forget that. Replacing one skill, it was replaced by one skilled maintenance labor who programs and maintains the machine, who cost you $100 per hour. So what did you say? $50 per hour? But we tend to forget one more thing. The Tesla plant gross fixed assets, because of this heavy mechanization, automation, and connectivity with each other of each machine talking, your fixed gross fixed assets is double than what you would find for an equivalent factory. Double. Who's going to look at depreciation and interest then? And this is exactly what happened. Higher capital cost of 4,000 per unit of capacity. Per unit of capacity. Higher capital cost, which means $550 per car of additional depreciation over 7 years. I'm not even looking at interest. And that is assuming you make 400,000 cars. This company cannot make money, this particular plant. How Tesla is declaring profits, is selling green points to others because of the cars they make. This factory can't. And that is something you have to keep in mind. Will you get quality? Let us see. These are all in public domain. There is an agency called JD Power which conducts several research for consumer durables. This is initial quality study, means it takes and measures vehicle quality in the first 90 days of ownership by consumers. The new study is based on responses from 87,282 purchasers and leases of new 2020 model year vehicles. Fortunately, it was done just before the first wave of COVID struck. It was fielded from February to March 2020. This was the first time Tesla allowed study of their vehicle. And believe it or not, Tesla vehicles were the worst among 32 major brands in its annual quality study. It was the first time that Tesla's cars have been ranked by an influential customer survey, now in its 34th year. Tesla cars suffered 250 problems per 100 vehicles as reported by customers compared to an industry average. Tesla customers surveyed complained of body panel accuracy, rattles, wind noise, paint jobs. I hope you are getting the picture. It does not guarantee quality. This is all nice story. So how do we look at smart factories? You know, all this integrated, etc., you do. Look at the investment required. What is the meaning of EBITDA, earning before interest, depreciation, and tax? Is it free? The expenses of depreciation and interest rocket sky high. Who's going to maintain these machines? That's another problem. Costly labor. So please understand the financial implications of this. Okay, I'll continue. Ravi, can you see the screen?
Yes, yes.
Okay.
Please go ahead.
Let us see how Toyota looks at it. Value creation on the shop floor results out of human-machine combination. Value creation in administration functions is a result of combination of human and information communication technology. What Toyota believes, the Toyota production system approach is simple. Improve the process first, make it stable, capable, repeatable. And only after that you invest in technology if need be. You commit an evil crime if you first invest in technology before improving the process. Very strong words. You commit an evil crime. And that to hear is need be. Who's this person? Satoshi Korewa. He was the information communication technology manager of Toyota. 34 years of experience with Toyota Manufacturing Company in car production preparation and information technology engineering. He specialized in factory automation, parts, logistics, and IT enhanced TPS. Keep your gross fixed assets low. That's what we believe. Now let us come back to smart factories. Let us look at potential advantages. There is flexibility, on-spot manufacturing to customer specification. You just feed it into the system and it schedules production, looks at available incoming parts, ordering incoming parts, when they should come, they track it, schedule production, no problem. On-spot it can be done. Actually, very little waiting time to start to produce if the material is available. So it fundamentally will work on pull system, not push. So there are some advantages. Full information on whereabouts of parts and components also is there. And you can react very fast as and when uncertainties arise. What are the potential disadvantages of smart factories? Your overall equipment effectiveness will be lower. Your output for that gross fixed asset will be lower. We call it exit rate or throughput. It can be lower on-time delivery because it looks at what is available and starts working on it. What about the security of data? What if somebody hacks in? That is a major problem. Very high installation time, very high pre-operative expenses. I hope you saw that conveyor system and how the parts are going. Such sophisticated machines, intelligent machines. Gross fixed assets will be so high. How to install it, debug it, start training people to using it. High pre-operative expenses, which will be high break-even point. You may find workers have reduced, but very high number of indirect operators, maintenance people will go up and they are costly. And one thing is very clear, SMEs will not be able to make such investments. Also, let us try and understand this. Please understand, we are talking about the Indian environment. A skilled labor in US costs $35 an hour. The average age is 39 years. And the supply dynamics is 2 million people will be added to the workforce in 10 years. This was 2020 study. Germany, the labor cost is $46 an hour with an average age 44 and a reduction in supply of labor in 10 years of 3 million. China, labor cost $1.8 an hour, average age 39. There are conflicting reports of supply dynamics. What will it be? I am assuming 70 million. And look at India, $1.3 per hour, average age 29. And we are going to add 100 million people in 10 years. That is roughly 1 crore per year. So you will understand that this is not going to give us return on investment. Gross fixed assets will be so high, your fixed expenses automatically becomes high. 10%, we are allowed 10 years depreciation, 10% of the asset value. You take 7% interest on the money. Your numerator will diminish, your denominator goes up, your ROI takes a beating. So what is the environment in which you are doing it? Be very clear. We have young labor force, additional labor coming in, labor cost is not going to shoot up. And look at Germany, US, they need it. They have a problem I don't have. Also, I have tried to see how to compare the performance of lean, batch, and smart factories. So relatively, if I look at output rate, throughput, volume versus the lead time, batch necessarily will be bad on lead. Lead will necessarily be the best on lead time. But look at smart factories. It'll be better than batch, but worse than lean. But look at the throughput. It will not give you the throughput the way lean and batch gives you. So is it worth it? We tend to forget it. Similarly, variety game. Smart will always score better than the rest on variety. But by giving variety, will they give you the volume? Batch, slightly less in variety compared to smart, but will give you larger volume. Please understand the output of the system. Lean, of course, gives best volume, but mixed variety is a problem because of simultaneous setups to be done on all the machines. I'm trying to show if mix changes relatively every day, every week, and volume changes every month, batch somehow has the best volume elasticity and the best mix flexibility, but it has long lead time. Smart, in terms of mix flexibility, will be better than lean, but not as good as batch. But volume elasticity, you can't do a damn with that factory setup because they are all interlinked. And lastly, I've tried to show you the break-even point for the same product. If you make it in batch, will be here. Lean will be here. I could not show it, otherwise single piece flow will be somewhere here. So my concluding comments are, smart factory has a flavor of dream of engineers supported by governmental benevolence. Smart factories do not score well on break-even point and ROI. They will not score well in India at all in developing economies. In fact, CIOs, Chief Information Officers and Chief Technology Officers will need to understand the cost versus benefits. To me, depreciation and interest has to be considered rather than EBITDA. It should be profit before tax. So to my mind, smart factories should not be considered as a revolution, but if at all can be applied in pieces which have to be created into a comprehensive lean framework. First, go for leanness, lean batch, and then see where would you like to connect what equipment in bits and pieces. Do not try to integrate everything. So my last few words are, industry must learn to walk first. Thank you.
Thank you so much,
Yeah,
Mr.
Ravi.
Yeah, thank you so much. Very clear, lucid communication and presentation that you have really made. Now, one question arises is, what should small companies do, SMEs do?
My answer to that is, stop even thinking about smart factories. You can't do a damn, and the big companies, even if they do it, are in for trouble, according to me, when it comes to working in India, in a developing economy. The cost will be prohibitive. Pre-operative expenses will be prohibitive. Even in an environment like United States, I gave the Tesla story. I'm waiting for results to come. Nobody seems to be having any smart factory in India. They are also doing it in bits and pieces. And I'm told Bosch has been a leader in that front. But again, they don't have a fully integrated system. So my point is, it's all very nice to talk about smart. There have been a lot of seminars and symposiums on it. Nobody seemed to be having it. I have asked for invitation to visit some facilities, and they are very, very careful to allow me in. They don't have it, is my understanding, is my view. SMEs, no way you can afford it unless you are on a suicide path. I mean, financial suicide, I mean. Yes, sir.
I guess a lot of noise is created by, I think, interested vendors who want to sell technology. And that is where I think we all get misled. And I think everybody who's attending here probably are intellectuals, I would say that, and we really get impressed. So we not only listen to all this, technology advancements and so on, but we also start talking
Yes.
somehow, not realizing that, what can be on the ground.
I can
So
add one more
excellent.
thing, Ravi. Sorry for interrupting you. Also, information technology people are very keen because it gives them additional business.
And
IT
jobs,
industry.
and jobs.
Yeah, and
If
jobs.
if you say that, I have implemented such and such technology, you can jump jobs, you can get salaries, all that you can do. So that's very interesting. I think someone has raised hand. Nistush, you
Yes.
would you allow, please allow them to
Yes.
ask.
So, yeah, Adarsh, you can unmute yourself and ask the question.
Good evening, Moradian sir. It was a
Good
wonderful
evening.
presentation, and it was good learning after attending your class after 10 years in SPJ.
So
So I
nice
have
to
two.
see you.
I have two questions related to this. One is, I agree with you. In India, human labor force apparently doesn't looks to be a challenge. But if you go little in depth on this question, you will get more engineers available than a qualified ITI person in majority of the industrial belts in India, whether it's in Pune or in Hosur or in Gurgaon belt. So the good workforce, I feel, you may correct me if I'm wrong, it has become slightly challenging now to find. So replacement of the workforce can be a potential problem in 10 years down the line. So in that scenario, will this automation not become handy uh, to go for? Question number two, especially in the areas of manufacturing where human working was hazardous and even now it is hazardous by the very nature of the process. Earlier we didn't had a solution, but now since we have this, is it not prudent to deploy all these robots and technologies, especially in a high temperature environment or hazardous chemical environment, selectively, so that you protect the workforce from all the hazards?
Yeah,
That
I'll answer your query. Good question. The second part I'll answer first. Safety is not negotiable. That's very clear. I don't care about return on investment at the time. It's not negotiable. Safety comes first. We talk about it. And if the work is done in a hazardous environment, not only that, if the work itself, over a passage of time, will kill the worker, even if it is done in a safe environment, and ergonomic studies show that you are reducing the life of the worker, I will have no hesitation in automating that process. I will have no hesitation because safety is not negotiable. So that's very clear. But that is not going to be a major chunk of the industry. It will be specific and very few jobs overall. The second question is, yes, I talked about the labor force entering. You talked about engineers. In this country, we are producing engineers and we have so many engineering colleges. Numbers are there. But what about the quality of the people we passing out? According to me, not even more than 20% are worth it. The remaining 80% are useless. And I have no hesitation in saying that. You sit in interviews and you find that the ITI guy at least has worked on the machine, has got hands-on experience, may not have intelligent answering capability, but the guy knows the job, and I would rather have an ITI or a diploma holder than the engineering graduate. I'm not suggesting all are bad, but my judgment based on interviews which I sit on my client side, the quality is useless, the numbers are there. So I don't know why engineering colleges exist. I mean, they are money-making rackets, and I will have no hesitation in saying it. Where are the facilities? The same thing is happening, and these are all privately run, most of them. Where is the quality being produced? And they are all AICTI approved. How come? These are major questions to be raised. After all, there are agencies which qualify the college. What is happening there? Do you know they don't have professors? And before the audit, the professors are brought in on paper and physically made to sit there. And after the audit, they go away. So that is the quality of the education we have been giving. I personally prefer ITI and diploma. I'm not suggesting I don't take engineers, we do. But then it's a big pain to pick. And so for some jobs, we need engineers. And we have no choice but to go through the pain. So others, I hope I've answered your query.
Yes, sir. Yes, sir.
Yeah. Any other
Thank
question? I think Chavan.
Right. Yeah, we have another question from Anurag. Yeah, you can unmute yourself and ask the question, Anurag.
Hello, yes, good afternoon, sir. Good afternoon, team, and thanks for the opportunity. Sir, it's really good to have you, and it's really good to see you, sir, after so much time. I attended your lectures from JBMS MFM batch 2018.
Oh. Hi, Anurag.
Yes, sir. Thanks. So my question is regarding your just explanation about ITI, the quality of ITI and the quality of engineers. I think the same thing has happened in around 10-15 years before in terms of agriculture industry. So earlier, the people were following the industry and they were willing to work in the industry, into the farms. But now, uh, the labor for the farmers are not available, and everybody is shifting to some other job, but not farming related activity. Same thing somehow is happening. The quality, the number of engineers are increasing, but the number of diploma and ITI people are not increasing. Somehow it looks like the engineering uh, being kind of a high status quo education and diploma, uh, and the other thing is not. So how to attain this, sir, so that uh, we have some kind of quality labor force coming in from ITI also?
Yeah, my suggestion has been that, these supervisors which we have above the worker level or operator level, don't have these engineers. Promote from within your ITI and diploma holders. After 5-7 years, they know how to run the machine. They know how to maintain the machine. We can train them in doing proper supervision and planning. And this is what we do in my client companies over a period of time. You can't just remove people who are there as supervisors and engineers. Train them. I have a plant manager in one of my client companies. He's not even ITI. He was a helper on the line. It's maybe a rare case, but there is a second one in the offing. His name is Mr. Mishra. I respectively call him Mishra ji. He was a helper, just completed schooling, worked on the printing line, learned printing, picked it up, became an assistant operator, became an operator, and then became a line supervisor. And then now he is a shift supervisor. The entire shift scheduling, etc., he has done it, and it has happened in 15 years. He now runs my Middle East plant as a plant manager. He speaks English. We trained him. He takes visitors around. He's very proficient in Excel. Look at every person you have with dignity and consider this person as a genius in hiding. It is our job to get them to come up. The other person, next one in the line, is one Mr. Jadhav. Fantastic guy. He's coming up the same way. So invest your time in these people, the ITI people. They will do a good job and make them seniors. You know, the Toyota plant, just for example, who are the supervisors, which they call as team leaders? They are senior workmen. Who are the group leaders? They are senior of the team leaders. We had this during the British days. We still have it in the railways. They were called foremen. We have done away with this category called foremen and brought in engineers. And you know something? There's a gang leader. In railways, you'll see gang leader. He leads a gang of people on some emergency basis. We have done away with this in industry because engineers were available. Go back. It's not a degeneration. Actually, you will get wonderful results and cost-effective results. And those guys, the churn of operators is much, much, much lower than engineers. I hope I've answered your query, Anurag.
Yes, sir. Thanks. Thank you.
Yeah, any other question?
If you have anyone else who has a question, you can either type it in the chat box or you can just unmute yourself and ask. Otherwise, Boman Moradian, sir, it was a fantastic session. It was like we felt should never end. The presentation and all the insights, all the real time stories. It's really really nice to listen all to all of this.
Ravindra, thank you very much for inviting me on behalf of KnoWerX. It was a pleasure meeting you after a very long time. At least give me an opportunity to meet, and we'll keep in touch. And thank you,
Actually,
Nistus, for
it's our
coordination.
pleasure. In fact, our pleasure and I would say, our fortune that you are here as a speaker.
My
So
pleasure, my
I consider
privilege.
this as my fortune.
Thank you.
Thank you so much. Thank you.
And thank you all the participants. If there are any queries, you can route them through KnoWerX anytime. Okay?
Yes, thank you everyone for joining in. If you enjoyed the session, we'll also have the recording very soon on YouTube, and the links will be shared with you. The next episode will be on 18th of June. We will send the details to you. You can always follow us on LinkedIn and keep updated with the upcoming events and all the certifications that we have. Thank you everyone for joining in. Have a great weekend ahead. See you again. Bye bye.
Thank you so much. Bye bye.
Bye-bye.
Bye bye.
Thank you.
Thank you, Ravi. I'll sign off.
Yes, sir. You can sign off.
Thank you, Nistus, for all the coordination.
Thank you, sir.
See you.